to begin that discussion. A good starting point for thinking about the global environment and the situation that we face is the story of Easter Island. And that might seem somewhat tangential, but I think in a fairly short period of time you'll understand where I'm going with this. Easter Island was discovered by Admiral Ragueneau, a Dutch admiral who was crossing the Pacific in 1722. It has the name Easter Island because he discovered it on Easter Sunday, or he came across it on Easter Sunday. And when he arrived there, he was appalled. He encountered a small population of inhabitants that he described as the most primitive people that he ever encountered in all of his travels throughout the world. Peoples that were living essentially in small hovels and caves. A large portion of their diet consisted of cannibalism. They were in constant war with one another, with different tribes warring against each other, and resulting in that cannibalism. And the problem that he encountered is that while these people were the most primitive people that he'd ever seen anywhere on the planet, there were signs of a fairly highly elaborate and highly developed civilization on Easter Island. In other words, there were ceremonial platforms with extensive writing on them. These platforms seem to be in alignment with the stars, meaning that whoever created them had fairly detailed knowledge of the stars, as well as navigation and so on and so forth. Furthermore, what most of you are probably fairly familiar with is that there were these stone statues all over the island. And those stone statues weighed 60 tons in some cases more. And many of them had sandstone hats on top of the statues that weighed themselves about 10 tons. And yet there were no draft animals. There was no sign of any kind of mechanized technology. There were no trees on the entire island. And the puzzle was, how did this come about? How did these things get created? How did these very primitive people do this? And there were all sorts of interesting theories about that up until fairly recently. In the late 1970s, I remember there was a movie that came out called Chariot of the Gods. And one of the things that it looked at a bunch of different things, but one of the things it looked at was Easter Islands. And it came to the conclusion that the Easter Islands, among a number of other places in the world, were definitive proof that we had been visited by people from outer space that had come down and put these things in place. Well, as it turned out, none of that was true. In fact, as more recent archaeological evidence has shown, the people that populated Easter Islands had migrated there from the Polynesian islands. They were the easternmost of the Polynesian islands, 1,200 miles from the nearest other island, and in very different climatic circumstances. And that furthermore, at the time that they arrived, which they estimate to be about 500 AD, the island was densely forested. So at some point during that period, from the 500 AD to 1722, the island became deforested, and this civilization rose and then collapsed. The upshot of it is that in the case of the Easter Islands are 20 kilometers in circumference, meaning you can hike around the island in a single day. And therefore, it would have been very easy for these Easter Islanders to understand the impact that they were having on their local environment. They first arrived with essentially a whole bunch of crops, most of which wouldn't grow on Easter Island. The only things that survived were sweet potatoes, chickens, and the Polynesian rat that was imported unintentionally with the other stuff. And the nice thing about the Polynesian rat, not so much the Polynesian rat, but the chickens and the sweet potatoes, is that they're really easy to grow. You just dig a hole, cut up your sweet potato in a bunch of chunks, put them in a few holes, come back several months later and dig them up and you've got fresh potatoes. And chickens, likewise, you let them run around, they peck around, there's no natural enemies, and when you want one, you lop off its head and put them in the pot. Meaning there was little or nothing to do, little in the way of labor requirements. And consequently, the population apparently put all of their efforts into building these ahus, these platforms, and these statues. and in the process used a fair amount of lumber to roll these in various ways, although more recent evidence seems to suggest that they actually moved the statues upright by sort of tilting them back and forth, but that's kind of irrelevant. Suffice it to say, they slowly deforested the island. And as they deforested the island, they would have certainly noticed that as soon as the roots of the trees were gone, so was the soil that they were growing their potatoes in. And as they moved further and further into deforesting more and more, they also certainly would have been aware that when they cut down that last tree, they cut down the ability to build dugout canoes, and therefore were stuck on the island. And yet, all of this, which would have been fairly obvious to a civilization capable of developing writing and all of this kind of stuff, did not prevent the competition between different clans within that, that essentially led to their own demise and their own self-destruction. Now, many have pointed to that this is a kind of an allegory for the situation that we face on the planet today. Essentially, we, like the Easter Islanders, are stuck on this little spot in the universe that we, regardless of what science fiction movies say, we're never going to get off of under any reasonable circumstances. And yet we also are seeing increasingly, especially given modern technology, the enormous impact that we're having on our environment. And it's fairly clear, especially given the science on climate change today, that we are very quickly approaching a brick wall somewhat similar to what the Easter Islanders are approaching. And we know exactly what we're doing. And the question is, can we turn the ship around before we hit that brick wall? And of course, turning a ship like the modern global economy and the international political economy around is a little bit like turning the Titanic around. It takes a long time. But the signs on that score are not particularly good. In 2005, for example, the United Nations issued its Ecosystems Assessment Report, which was the most extensive attempt by the United Nations, by the international community, to gauge the impact of human societies on the planet's ecosystems. And it came to some rather alarming conclusions. It found that in the last 50 years, rising human populations have polluted and overexploited 2/3 of the ecosystems on which life depends. It went on, that included clean air and fresh water. It went on to state that by the middle of the current century, most of those ecosystems will be in a state of collapse. And concluded finally that the ability of the planet to support future generations of humans can no longer be taken for granted. I found this report in page 3 of the Science Times, of the New York Times, and then went looking for various other publications, and in no publication that I found did it make the front page, or even the front, in the Toronto Star actually, it made the front section, but page 23. A little blurred. That's pretty alarming, given the conclusions that the report came to, and given that it was based on the participation by over 2,000 scientists from over 190 different countries, and represented in that sense the scientific consensus of the planet. That's kind of pretty alarming. It's interesting in that context to point out that your textbook, which on the whole I find is quite useful and quite instructive, focuses almost its entire discussion on the global environment on climate change. And paints a relatively benign picture of what climate change is all about. In other words, in the concluding paragraph, it states that, well, one of the reasons why climate change hasn't been dealt with as much as for example, the ozone threat, is because the costs of dealing with it would certainly be much higher, but also the benefits of doing so would be much lower. In other words, that according to their computer estimates, failing to deal with it, in other words, global warming, would only have an impact of roughly 2% on global GDP. I'm not sure I buy that. In fact, I'm quite sure I don't buy that, in large part by virtue of the fact that we really don't know what we're dealing with. And the most knowledgeable scientists are pointing to problems that would certainly point in a very different direction. The overall scientific consensus is that any CO2 concentration in the atmosphere over 350 parts per million will lead to irreversible climate changes. Anyone know where we're currently at? Did I put it up there? 400 parts per million. Yes, you're right. I did put it up there. Thank you for pointing that out. Somebody's paying attention. 400 parts per million. In other words, we not only have to freeze our current carbon levels, we actually have to bring them down fairly significantly. The other thing that seems fairly evident is that increasingly there are positive feedback loops that are being activated through the current level of global warming, as far as it has gone so far. What I mean by that are, well, a negative feedback loop is like your thermostat. It gets too hot, your thermostat takes actions to counter that, to bring the temperature back down. If it gets too cold, it turns on the furnace and counters that. A positive feedback loop is the opposite. It's something that reinforces a particular tendency. And in the case of global warming, one of the most common positive feedback loops that's pointed to is that the ice caps are melting at both ends of the planet. The ice caps are to a large extent white and therefore reflect most sunlight back into the atmosphere. If they melt, they are replaced by blue water, and blue water absorbs most of that heat. And that means that rather than counteracting the overall heating, global warming will accelerate that overall heating. Furthermore, another very frightening positive feedback loop is in regard to methane. The permafrost in northern Canada and northern Siberia apparently contains enormous quantities of methane, which is stored within the soil and frozen within the soil. But as that permafrost starts to melt, it starts to bubble up. And methane is 20 times more powerful as a greenhouse gas than carbon dioxide. Again, pushing things further in that direction. The upshot of that is that we are coming very close to destabilizing the overall support systems upon which the ecosystem, including ourselves, depend. And there are some pretty significant indications of that. Biodiversity loss at this point is somewhere between 100 and 1,000 times the normal rate of extinction. There is a normal rate of extinction as well as the emergence of new species, but they're disappearing far, far faster than they're being created. Habitat destruction. 60% of all ecosystems are irreversibly degraded, according to the UN's report. Land degradation. Increasingly, more and more land is turning to deserts in places like sub-Saharan Africa, and indeed also in North America. Land degradation and desertification are significant problems. Ocean stress. 90% of all fisheries are overexploited or are possibly in the state of collapsing, like the cod fishery off of Newfoundland. Freshwater water demand vastly outstrips overwhelms the aquifers and rivers upon which it is based. And lastly, carbon dioxide. Furthermore, of course, not only the impact of our environment is problematic, but also population. Populations have been growing rapidly, in particular in the last century and a half or so. Up until the turn of the 20th century, the human population had never exceeded 1 billion people. Today it's 7 billion. And even prior to the 19th century, there were significant famines in various parts of the world, meaning there were instances in which those populations outstripped the resource base upon which they depended and ultimately ended up collapsing as they did in Easter Island. But today that is much more the case on a planetary basis. Populations include 1 billion in developed countries, roughly, and 6 billion in developing countries. And that's expected to continue, such that by 2025, global populations will be 8 billion, and by 2050, 9.4 billion. 90% of that growth is in developing countries. And even if developing countries today imposed a limit on births that would only result in a replacement of the level of their populations, populations in those parts of the world will continue to grow for at least another 50 years. The reason for that is because the life expectancy of those that are born today is far longer than the life expectancy of those that are old today. And that means that even if there's no real population growth, population numbers nonetheless would continue to rise. Is that a problem? Well, according to Julian Simon, it's not. Julian Simon is a prominent, or was rather, he died a couple of years ago, a prominent economist, taught at Harvard for years, and his final book was called The Ultimate Resource. And guess what he thinks is the ultimate resource?
People.
Humans. That's right. Humans are the ultimate resource. And he argues that really, although we talk about overpopulation, in fact we're underpopulated. And there's lots of evidence to suggest that we're underpopulated. In particular, he says that wages have been rising globally. And if people are in shortage, if there's too many people, wages should be falling, not rising. And that clearly indicates that there's not enough people, not that there's too many. Furthermore, he argues that all of these alarmists that point to the problems with the environment are all full of crap. He argues that there is no shortage of land, that technology will easily be able to keep up with the demand for land, that in the future we could produce all the food necessary to feed the entire planet, according to him, on the limited land mass available just in the state of Massachusetts and Connecticut combined. And furthermore, we could reduce that even further by producing 2 and 80-story buildings, which that could be devoted to growing food. You can read that, that's interesting. But in any event, probably not all that realistic. The reality is that the vast majority of the population continues to exist in relative degrees of poverty, a sizable portion of which in absolute poverty. Which is defined as $370 per year by the UN. And in places like Rwanda, over 80% of the population lives at that stage. How do we conceptualize all of that? And how do we deal with all of that? Well, one way of thinking about this is what has in the field of industrial ecology become known as the master equation. And the master equation is, where I wrote up there, I equals P times C times T. What that P stands for is that the impact that we have on the environment globally is a function of population. Fairly obviously, the bigger the population, the bigger the impact. Zero population, no impact. Multiplied by consumption. The more that population consumes on a per capita basis, the greater the impact on the environment. Again, that seems pretty straightforward. The problem is population isn't going down, but we could compensate for that by consuming less. Is that likely to fly? Not in North America. And I doubt it will occur in many other places either. The last variable is T, and that stands for technology. And technology in this context does not mean your individual gadgets or something along those lines.